Right. Today we'll discuss another concept, that is SN2 reaction. In the previous class we have discussed SN1 reaction, the mechanism of SN1 reaction. Now we'll study the mechanism of SN2 reaction. So already I have given the idea about SN, means nucleophilic substitution reaction. So SN, here also we'll take the same example, that is the reaction with aqueous base, in which the nucleophile is OH minus. So in place of chlorine I have to write OH. This is the example for a nucleophilic substitution reaction under SN2 reaction. Why it is SN2 means the type of alkyl halide here is primary alkyl halide. Primary alkyl halide. In case of SN1 reaction, the tertiary alkyl halide will react. In SN2 reaction, the primary alkyl halide will react. And how the mechanism follows, and why it is SN2 only. What is this 2 means? 2 means bimolecular. So why we are using bimolecular means the mechanism involves only one step, whereas in SN1 it involves 2 steps. Right. In SN2 it involves only one step, means see here, in the first step itself the hydroxide ion will attack the alkyl halide. Where it attacks the alkyl halide? Usually it attacks this carbon which carries the halogen atom. From which side it attacks? Whether from front side or back side? Usually only from back side. But in case of SN1, there is a possibility of front side and back side because of planar structure of carbocation. But here this is not planar structure, this is tetrahedral structure. So the chance of attack is only from back side but not from front side. Why it is not from front side? Because in front side there is a large sized chlorine atom. It occupies more space here, so that the hydroxide ion cannot attack from front side, whereas from back side there are smaller size hydrogen atoms. There is sufficient space to enter and attack this carbon atom. So that initially we'll get a transition state. Transition state is nothing but which is highly unstable state. It cannot exist. It is just an assumption. Might be the process takes place like this. That is the assumption here. See here, the hydroxide ion is attacking from backside. At the same time, the chloride is eliminating. It is escaping from the molecule as Cl minus, so that the OH minus in the resultant molecule occupies the place exactly which is opposite to the configuration of alkyl halide. That means in case of alkyl halide, the chlorine atom is on right side, whereas here the OH minus is on left side. Hence here the inversion of configuration takes place. Inversion means opposite. And what is what the number represents? 2, bimolecular. What is this bimolecular? Means this is slow ionization. Initially the attack of OH minus on this carbon takes place slowly. So as I said in the earlier class, whichever the slow step is, in that step we can determine the rate. This is RDS, means rate determining step. So as this in the rate determining step, the rate is depending on, we have the concentration of alkyl halide and also base, that is OH minus. Both are present here in the slow step, whereas in the SN1 reaction only alkyl halide, so that the order is 1, it is unimolecular. Whereas here the power of the concentration terms 1 and 1, 1 plus 1, it is 2. The order is 2, hence it is bimolecular. Hence it is bimolecular. And the next step is very fast. As soon as the transition state is formed, the chloride immediately eliminates from the molecule and the product formation takes place. So in case of SN1 reaction also, this is first step. Immediately it attacks the carbocation, forms a racemic mixture. And the reactivity of alkyl halide is exactly opposite to the SN1. Methyl halide, primary, secondary, tertiary. Now, why primary alkyl halide reacts fastly in case of SN2, whereas tertiary in case of SN1? Because if I want to make this tertiary butyl halide undergo SN2 reaction, so according to SN2 reaction, only one step, it involves one step. In the first step itself, the alkyl halide should attack here. So alkyl halide, if that alkyl halide tries to attack from front side, but due to the larger size bromine atom, it does not takes place. If it tries to attack from back side, all the methyl groups are very large groups, so there is no sufficient space here from back side and also from front side, and that's why initially the tertiary butyl bromide ionizes into a planar carbocation after the formation of planar carbocation. So this is the plane of the molecule, so that the hydroxide ion in the second step can attack from front side or from back side. But it does not happen in case of primary alkyl halide, because from back side there is a large space, sufficient space, so that it can attack, and hence it is SN2 reaction, whereas the tertiary butyl halides undergo SN1 reaction. So this is about the mechanism of SN2 reaction. Thank you.